Nvidia lost $127 billion in market value in a single day. Not from a war, not from a crash, not from a scandal. From one announcement out of China. And the company that caused it was not supposed to be able to compete. That is where this story starts. For decades, one company has controlled the entire future of computing. That company is ASML, a Dutch firm based in Veldhoven, Netherlands. They build machines called EUV lithography systems. Without these machines, you cannot manufacture advanced chips. Not the ones inside your phone, not the ones powering ChatGPT, not the ones running military systems. Every single advanced chip on the planet is made using ASML equipment. Each machine costs between $150 million and $400 million, weighs 180 tons, contains over 100,000 precision parts, and took nearly 20 years to perfect before the first commercial system shipped in 2019. No other company on Earth makes them. No backup, no alternative, no competition. That was the entire point. When the United States realized this monopoly could be used as a weapon, they moved fast. In 2018, Washington pressured the Dutch government to block ASML from selling these machines to China. The export ban was total. Not a single EUV machine ever shipped to Chinese soil. Then in October 2022, the U.S. Commerce Department launched the most aggressive semiconductor export controls in history, cutting China off from AI chips, design software, and advanced manufacturing tools. In September 2023, even older DUV lithography machines were restricted. American officials were confident. Without EUV, China was permanently stuck. The strategy seemed airtight. Then something happened inside an unmarked building in Shenzhen. The man at the center of this is Lin Nan, a Chinese researcher who spent years at ASML in the Netherlands as the head of EUV light source technology. He returned to China in April 2021 and quietly joined the Shanghai Institute of Optics and Fine Mechanics under the Chinese Academy of Sciences. What happened next was not publicly known for years. Lin Nan and his team filed 8 patents on EUV light sources in just 18 months. Workers inside the classified facility were given false identity cards. Signing bonuses ranged from $420,000 to $700,000 plus housing subsidies. One recruit reportedly recognized former colleagues who were also using fake names. Nobody outside the facility could know what was being built. The effort was classified as a national security project. In December 2024, Lin Nan's team published research showing they achieved 3.42% conversion efficiency in generating EUV light. To put that into perspective, the Advanced Research Center for Nanolithography in the Netherlands achieved only 3.2% in a comparable 2019 experiment. A Chinese government-backed team had just surpassed the Dutch benchmark. Their method, called laser-induced discharge plasma or LDP, vaporizes tin between electrodes using solid-state lasers rather than ASML's CO2 laser approach. Reuters confirmed in December 2024 that a working prototype was completed inside the high-security facility in Shenzhen and was already undergoing testing. China officially targets 2028 for chip production using this machine, though sources close to the project say 2030 is more realistic. The machine has not yet produced working chip, but ASML's own CEO Christoph Fouquet publicly told investors in April 2024 that China would need many years to develop this capability and was at least 10 to 15 years behind. That statement has aged badly. While Lin Nan was working on the EUV machine, Huawei was attacking from a completely different angle. Their Ascend 910C chip uses a dual chiplet design, combining two 910B processors into a single package to roughly double computing power. Industry estimates put its performance at around 780 to 800 teraflops of BF16 processing, compared to Nvidia's H100 at 2000 teraflop. That is roughly 40% of Nvidia's raw power, built without access to EUV equipment, manufactured by SMIC using an older 7-nanometer process. The yield rate sits at only 20% to 30%, far below the 70% typically needed for commercial profitability. The Chinese government is subsidizing this gap directly. In 2024, government subsidies accounted for 87% of SMIC's operating profit. Without that support, SMIC would have earned just $62 million in operating income. China is not running this like a business. They are running it like a national security program. ByteDance, BYD, China Mobile, and SenseTime are already ordering Ascend 910C chips in volume. For Nvidia, the damage is already severe. Their H20 chip, specifically engineered to comply with earlier export restrictions, was banned anyway. Nvidia disclosed in regulatory filings that this single decision would cost them $5.5 billion immediately. J.P. Morgan analysts warned the total 2025 revenue loss from China could reach $16 billion. China represented 13% of Nvidia's total revenue in fiscal 2025, down from 26% just 3 years earlier in fiscal 2022. In certain segments of China's AI chip market, Nvidia's share has effectively gone to zero. ASML is feeling it too. Their stock dropped 15% in a single day in October 2024, the largest single-day fall since 1998. China was ASML's largest market in 2024, representing roughly 10 billion euros in sales. That share is now projected to drop from 49% in mid-2024 to around 20% by 2026. Nvidia's own CEO Jensen Huang recently called Huawei a formidable competitor and acknowledged that American export restrictions have made them more innovative, not less. Every sanction that was supposed to slow China down handed their domestic industry a captive market, a clear mandate, and unlimited government funding. China has invested over $150 billion in semiconductor development since 2014, with another $300 billion committed through 2030. The strategy of containment has not just failed. It has built the very competitor it was designed to prevent. The question now is not whether China will achieve EUV independence. It is how fast, and what happens to the global semiconductor industry when they do. Of 2-nanometer chips using gate-all-around transistor technology for the first time, with yields reportedly above 60%. Apple, Nvidia, and AMD already locked in capacity. Samsung entered 2 nanometers production too, but is stuck around 40% yield compared to TSMC's 90% at 3 nanometers, a gap that translates to billions in wasted silicon every single month. TSMC itself says it won't reach 1.4 nanometers until 2028, and true 1-nanometer mass production isn't expected before 2030. Every step of that roadmap depends entirely on ASML machines that China cannot legally buy. Meanwhile, Huawei's Ascend 910C is already shipping at roughly 780 to 800 teraflops of BF16 performance, about 40% of Nvidia's H100 at 2000 teraflop. Huawei plans to ship over 700,000 Ascend units in 2025 alone, scaling to 1.6 million chip dies by 2026. The next chip, the Ascend 910D, reportedly targets H100 level performance on specific workload. When that report circulated on April 28, 2025, Nvidia lost 2% of its market value in a single trading day before a single specification was independently verified. China currently depends on foreign chips for 60 to 70% of its AI infrastructure. By 2026, analysts project that falls to 40 to 50% as Ascend production scales. The direction is not reversing. The 1-nanometer chip is real science. The EUV machine is a real prototype. The gap is real and measured in years. But the team trying to close it has $75 billion, 50,000 dedicated engineers, and absolutely nothing to lose. Watch this space. On December 6, 2025, A patent quietly published by China's National Intellectual Property Administration stopped semiconductor executives cold. The document's title was Dry and Bureaucratic: Metal Integration Method for Manufacturing Integrated Devices, and for a few hours nobody noticed it. Then the engineers started reading. And the silence became panic. Because buried inside that filing was something that should not exist. A detailed technical blueprint from Huawei, the Chinese tech giant locked out of advanced chip-making equipment since 2019 for manufacturing 2-nanometer chip. The same cutting-edge technology that TSMC, Samsung, and Intel collectively poured over $100 billion into developing. Except Huawei is claiming they can do it without the machines they are legally banned from buying. To understand why that matters, you need to understand the machines. ASML, a Dutch company, is the only manufacturer on Earth of EUV lithography machines, the absolute gatekeepers to advanced chip production. Each one costs over $150 million. They weigh 180 tons. They require 40 shipping containers just to transport. Inside, they fire laser-produced plasma at tin droplets to generate light with a wavelength of just 13.5 nanometers, a beam so precise it etches circuit patterns onto silicon that make a human hair look like a highway. The entire semiconductor industry agreed on one thing: without EUV, you cannot manufacture chips below 7 nanometers. That was not an opinion. That was physics. Only TSMC, Samsung, and Intel had these machines. In 2022, the Netherlands blocked ASML from selling to China. The cage was complete. Then Huawei started doing things that were not supposed to happen. In August 2023, they released the Mate 60 Pro smartphone. Western analysts tore it apart looking for the trick. There was no trick. Inside sat a genuine 7-nanometer Kirin 9000S chip, manufactured by SMIC, China's largest chipmaker, using older DUV deep ultraviolet lithography machines that nobody had bothered to sanction because everyone assumed they were too primitive to matter. TechInsights, the leading semiconductor research firm, confirmed it after a full teardown. Zero ASML. Zero EUV. A chip that defied a decade of Western assumptions, shipping in a phone that sold out within minutes. Then in 2024, the Kirin 9030 pushed toward 5-nanometer equivalent performance. Every time the world drew a line and said China cannot cross this, Huawei and SMIC crossed it anyway. So what exactly is in this new patent? The method is called self-aligned quadruple patterning, or SAQP. The idea is ruthlessly simple in concept and brutally complex in execution. EUV draws an ultrafine circuit line in one single laser pass. SAQP draws that exact same line in 4 separate passes using older DUV equipment, with precision-engineered stencils and spacers guiding each pass down to atomic-level accuracy. The patent describes 5 spacer layers and exotic metals, ruthenium, copper, and cobalt, woven together to create metal interconnects spaced less than 21 nanometers apart. On paper, it is a work of engineering genius. In practice, it is one of the most expensive gambles in the history of chip manufacturing. Here is the brutal math. TSMC running their 7-nanometer process with EUV achieves around 90% yield, meaning 90 out of every 100 chips they produce work perfectly. SMIC doing the same 7 nanometers node with DUV multi-patterning hits only 50%. Drop to 5 nanometers and that bleeds down to 30%. Now push all the way to 2 nanometers. Industry analysts estimate initial yields using Huawei's method could fall as low as 10 to 15%. That means 85 to 90 chips dying on the production line for every one that survived. Chinese-made chips already cost roughly 40% more than an equivalent TSMC chip, even after Beijing subsidizes around 30% of production costs. At a 10% survival rate on 2 nanometers, each working chip becomes extraordinarily expensive. And China is doing it anyway. Because this was never a business decision. Between 2022 and 2024, Beijing funneled over $75 billion into domestic semiconductor development through state banks, sovereign wealth funds, and tax incentives. More than 50,000 of China's brightest engineers were reassigned from companies like Huawei and SMIC into classified research facilities. In 2024 alone, government subsidies covered roughly 87% of SMIC's entire operating profit. Beijing is not building chips to make money. It is building chips to make sure no foreign government can ever again threaten to switch off China's entire technology sector with a single policy memo. That is a different calculation entirely, and no amount of economic logic changes it. But the patent is only half the story. In early 2025, reports emerged that China was testing its own extreme ultraviolet lithography machine, a prototype believed to be codenamed Hyperion 1, at Huawei's Dongguan facility. The approach is completely different from ASML's method. Instead of firing high-powered lasers at tin droplets, the Chinese system vaporizes tin between electrodes using high-voltage electrical discharge, a technique called laser-induced discharge plasma, or LDP. Both methods generate the same 13.5 nanometer EUV wavelength needed for advanced chip etching. The current prototype produces between 100 and 150 watts of EUV power. Commercial manufacturing requires at least 250 watts. ASML's machines produce over 500 watts. The gap is real, but the fact the prototype exists at all was enough to send ASML's stock down 7% the day the news leaked. Meanwhile, TSMC is not standing still. Their 2-nanometer process entered mass production in 2025 using next-generation EUV with high numerical aperture optics and gate-all-around transistor architecture. They spent over $40 billion on R&D and new fabrication facilities. Their yield from day one sits at 85 to 90%. Their customer list reads like a who's who of global technology: Apple, Nvidia, AMD, Qualcomm. TSMC controls approximately 60% of the global foundry market and nearly 90% of advanced chip manufacturing. None of those customers are leaving anytime soon. But if Huawei cracks 2 nanometers production, even at higher cost, they can supply China's domestic market of 1.4 billion consumers. Companies like Xiaomi, BYD, Alibaba, and ByteDance would route to Chinese foundries instead. That is potentially 30 to 40% of global semiconductor demand shifting ecosystems permanently. A patent is not a chip. There is zero evidence today of actual 2 nanometers chips being produced at any scale using this method. Going from patent to mass production typically takes 5 to 7 years minimum, and TSMC spent 30 years building relationships with over 600 global suppliers to get where they are. That ecosystem cannot be rebuilt overnight. But here is the thing nobody can argue with anymore. In 2019, a 7 nanometers chip without EUV was called physically impossible. It existed by 2023. A 5 nanometers equivalent without EUV was called physically impossible. It happened in 2024. The 2 nanometers patent may be the next chapter in that same story. Or it may sit in a drawer and never see production. Nobody actually knows. But the wall that everyone said was unbreakable, it has cracks in it now. And the next 24 months will tell us exactly how deep those cracks go. The year is 2025, and something impossible just happened in a secret facility in Dongguan, China. Huawei, the company that was supposed to be dead after US sanctions, just successfully tested their own extreme ultraviolet lithography machine. If you don't know what that means, let me put it simply. They just built the most complex piece of technology on planet Earth, a machine that only one company in the entire world has been able to manufacture until now. And they're using it to make 3 nanometer chip. The same experts who said this would take China 15 years are now watching their predictions crumble in real time. Let me explain why this is absolutely insane. An EUV machine is not just another piece of factory equipment. These machines cost over $350 million each, more expensive than a Boeing 787 Dreamliner. They require 40 shipping containers just to transport. Inside, they use light with a wavelength of exactly 13.5 nanometers to etch circuits onto silicon wafers that are 30,000 times thinner than a human hair. For decades, only ASML, a Dutch company, could build these machines. They had a complete monopoly. No competition. Zero. And when the US government pressured the Netherlands to stop selling these machines to China in 2019, everyone thought China's semiconductor dreams were finished. Here's what happened instead. In 2019, the Trump administration hit Huawei with sanctions, cutting them off from American technology and advanced chip tools. ASML, under pressure, stopped shipping EUV machines to China. Huawei's chip-making partner SMIC, which stands for Semiconductor Manufacturing International Corporation, was stuck using older DUV technology, which maxes out at 7 nanometers. The sanctions appeared to work perfectly. China's access to cutting-edge chip technology was completely blocked. Western analysts, semiconductor experts, and policymakers all agreed this was game over for China's chip ambitions. But instead of giving up, China went into full wartime mode. They poured billions of dollars into research and development. Xi Jinping made semiconductor independence a national security priority, comparable to food security or energy independence. Universities, private companies, and state-owned enterprises were coordinated in a massive push toward technological self-reliance. And now, in 2025, we're seeing the result. Huawei didn't just try to copy ASML's approach. They invented something completely different called laser-induced discharge plasma, or LDP. While ASML uses laser-produced plasma that blasts tin droplets with high-powered lasers, Huawei's LDP method vaporizes tin between electrodes and zaps it with high-voltage discharge. This creates plasma that emits the exact same 13.5 nanometer wavelength of extreme ultraviolet light needed for chip manufacturing, but through a fundamentally different mechanism. And here's the kicker. It's simpler, smaller, and potentially much cheaper than ASML's hulking machines. This LDP-based EUV system is already in testing at Huawei's Dongguan facility. A Chinese firm, rumored to be China's lithography champion, filed a patent for this technology in 2023, and now it's coming to life. Trial production is scheduled for the third quarter of 2025, which is just months away. Mass production is targeting 2026. If this works, China could flood the market with homegrown 3-nanometer chips, completely smashing the sanctions wall that was supposed to contain them for the next decade. But this isn't just about Huawei. SMIC, China's top foundry, is in on this too. Together, they're not just trying to catch up. They're aiming to leapfrog Western technology entirely. A South China Morning Post report highlighted that a Harbin team achieved an EUV light source breakthrough, also hitting that critical 13.5 nanometer mark. Meanwhile, the Shanghai Institute of Optics and Fine Mechanics, led by researcher Lin Nan, developed an extreme ultraviolet light source platform with power output and operational stability that specialists describe as internationally competitive. Multiple research teams across China have simultaneously achieved breakthroughs in different aspects of EUV technology, including light sources, optics, and lithography systems. This coordination suggests a well-orchestrated national strategy rather than isolated research effort. Now let me explain why 3 nanometers matters so much. Smaller chips mean exponentially more power with less energy consumption. A 3-nanometer chip can pack nearly twice as many transistors into the same space as a 7-nanometer chip, dramatically increasing processing power while reducing energy consumption by up to 30%. Your next phone could run advanced AI models directly on the device. Cars could process massive amounts of sensor data in real time for truly autonomous driving. Quantum computing could get a massive boost. The West's lead in this technology has fueled everything from Nvidia's dominance in artificial intelligence to Apple's iPhone empire. If China cracks 3 nanometers domestically, they're not just joining the game. They could completely rewrite the rules. And the evidence suggests they're already making serious progress. Back in 2023, when Huawei released smartphones powered by 7-nanometer chips despite all the sanctions, Western analysts were absolutely stunned. The chips were manufactured by SMIC using advanced EUV techniques, demonstrating that China had found workarounds to technological barriers everyone thought were insurmountable. Then in February 2025, Huawei's founder told Xi Jinping directly that chip shortages were easing. This statement, coming from Huawei's leadership to China's president, signaled confidence in their domestic chip production capabilities. Even more telling, Nvidia, the world's leading AI chip manufacturer, started warning investors about Huawei's AI chip gains. When Nvidia publicly acknowledges a Chinese competitor's progress, that validates the threat level. In fact, Nvidia's market value dropped $127 billion in a single day after Huawei announced their Ascend 910C AI chip, which reportedly matches the performance of Nvidia's flagship H100. ASML's CEO said in December 2024 that China was still 10 to 15 years behind without EUV technology. Well, that gap is shrinking at a pace nobody predicted. But let's be clear about the challenges that remain. China is still years behind on manufacturing scale. ASML's ecosystem took 20 years to perfect. Huawei's LDP technology is promising but still unproven at commercial scale. Current production yields are estimated around 20 to 30%, far below the 70% typically required for commercial viability and nowhere near ASML's machines that achieve yields exceeding 90%. Trial glitches could easily delay mass production, and even if they succeed, initial yields will likely lag TSMC's polished manufacturing processes. Manufacturing semiconductor equipment at laboratory scale differs vastly from reliable mass production. A research team at Peking University published something in Nature Electronics that made every chip engineer in Silicon Valley stop and stare at their screens in disbelief. They built an analog computing chip using resistive random access memory that processes calculations 1,000 times faster than Nvidia's H100 GPU while consuming 100 times less power. And here's the kicker. They built it using older 7-nanometer manufacturing technology that the United States never bothered to sanction because everyone assumed it was too primitive to matter. Jensen Huang saw this coming. At the Financial Times AI Summit in London just weeks ago, the CEO of Nvidia stood on stage and said something nobody expected to hear from the man who built a $5 trillion empire selling GPUs to the world. He said China is going to win the AI race. Not might win. Will win. When the person who literally powers almost every major AI model today tells you his own technology is approaching obsolescence, you need to pay attention. Let me explain what just happened because this changes everything. For the past 100 years, we've been doing computing wrong. Every computer you've ever used,